Now, elastic and inelastic collision. Elastic and inelastic collision. Now here, so what is elastic collision? The collision in which kinetic energy is conserved. Kinetic energy is conserved is called as elastic collision. Kinetic energy conserved means kinetic energy before collision and after collision it is same. In elastic collision, two conditions are satisfied. First one, momentum conserved. Momentum means momentum is after collision and before collision. Both the momentum must be same. Then second one is kinetic energy is conserved. So this not word is a printing mistake. So kinetic energy is conserved. Second one and third point here, coefficient of restitution for perfectly elastic collision is 1. That is E is equal to 1. We represent restitution by E. Now what is coefficient of restitution that we learn in the next article? But here you remember in elastic collision. So for elastic collision, you have to remember momentum conserved, kinetic energy conserved, and coefficient of restitution is 1. Now after that, you remember here one example. Collision between small particle like alpha particle, proton, neutron, electrons is an elastic collision. As well as collision between any two air molecule is also elastic collision. Now let's see inelastic collision. The collision in which kinetic energy not conserved. This not word is very important. That is the inelastic collision. In inelastic collision, two conditions are satisfied. First one, momentum is conserved. Means momentum is conserved in both elastic and inelastic. Okay, so momentum after collision is equal to momentum before collision. Second condition is kinetic energy not conserved. Kinetic energy not conserved here. Coefficient of restitution is 0. That is, we can write E is equal to 0. So coefficient of restitution in perfectly inelastic collision is 0. Now, how it is coming 0 that we learn in the another article. So for example, collision between utensil, accident between car and truck, these are the example of inelastic collision. Now, let's see coefficient of restitution. Now, what is coefficient of restitution? So this coefficient of restitution expressed in what extent the collision is elastic or inelastic. And based on this value of this restitution, we can decide the collision is elastic, inelastic, or what extent it is elastic or inelastic. Now, what is coefficient of restitution? You can see this definition here. The coefficient of restitution between two colliding bodies or collision bodies is defined as ratio of magnitude of relative velocity after collision to the magnitude of relative velocity before collision. So here, magnitude of this relative velocity after collision to the magnitude of relative velocity before collision. We write here formula. Relative velocity of separation means after collision to the relative velocity of approach means before collision. Or you can write in another word also, the ratio of relative speed of separation to the relative speed of approach is also called as coefficient of restitution. Now here, for perfectly elastic, let me write the two cases here. Case 1, for perfectly inelastic collision, we are writing for inelastic first. The colliding bodies stick together and move with common velocity. So for example, when the collision is inelastic, then object collide, they stick to each other. I mean, this is the first object, this is second object. When they collide, this is initial velocity of first object, this is second object, initial velocity, they stick and move with common velocity. Means final velocity of both the object is same. So here we can write V1 and V2 both are same because the stick can move with common velocity. So here I written V1 is equal to V2. So if V1 is equal to V2, then restitution is coming 0. Because here we can write relative speed of separation. So speed of separation means V2 minus V1. And speed of approach means U1 minus U2 we can write. Then if I substitute here V1 and V2 both are same in this equation, then we get E is equal to 0. So for perfectly inelastic collision E is 0. Now case 2 we can write here for perfectly elastic collision. Relative velocity after collision is equal to relative velocity before collision. Means this relative speed of separation and relative speed of approach both are same. Or we can write here relative velocity after collision is equal to relative velocity before collision. Or we can write here. So V2 minus V1, sorry, V2 minus V1 is equal to U1 minus U2. So if they are same numerator and denominator, then E is coming 1. So here we get E is equal to 1. So this is 1 for perfectly elastic collision. Now you remember here, if the restitution is 1, then it is perfectly elastic collision. If it is 0, then it is perfectly inelastic collision. And if this coefficient of restitution is close to 1, then we can write the collision is nearly elastic. And if the restitution is close to 0, then we can write it is nearly inelastic.